Solve the second order differential equation. Y double dash minus 7y dash plus 12y equal to 2 e raised to 4x. Here, in order to solve a second order differential equation of this kind, we have to first define complementary function and then particular integral. So our total solution will be y equal to complementary function plus particular integral. In order to find this complementary function, we have to put RHS equal to 0 and solve LHS part. So this will be, writing this in d operator form, this will be d square minus 7d plus 12 into y equals 0. This we can find by the method of usual solving of second order polynomial equation, that is, this is in the form x square minus 7x plus 12. So solution will be d equal to minus b plus or minus root of b square minus 4ac by 2a. So minus b plus or minus root of b square minus 4ac divided by 2a. So this will be 7 plus or minus, so 7 plus or minus root of 49 minus 48, that is 1 divided by 2a, that is 2. So this will be 7 plus 1 8 by 2, that is 4, or 7 minus 1 6 by 2, that is 3. So our complementary function becomes y equal to a e raised to 4x plus b e raised to 3x. Now we have to find particular integral. In order to find that, we have to put d square minus 7d plus 12 into y equal to 2 e raised to 4x and then solve that part. Here in RHS we are having 2 e raised to 4x. But in our complementary function that we have found already, there was 1 e raised to 4x term, because we got this one as the complementary function. Since there is already 1 e raised to 4x term in this complementary function, we have to take initial guess of particular integral as a x or in whichever constant, maybe we can write a1 x e raised to 4x. Why I have taken this x here? Because in complementary function we already got 1 e raised to 4x term. So here in particular integral we can't take the same just a1 e raised to 4x. We have to take one x here. Now we have to find the first derivative of this term. That will be a1 into derivative of x e raised to 4x. That is, first function into derivative of e raised to 4x is 4 e raised to 4x plus e raised to 4x into derivative of x is 1. This will be a1 e raised to 4x multiplied by 4x plus 1. Then we have to find second derivative, that is y double dash equal to a1 into e raised to 4x into derivative of 4x plus 1 is 4 plus 4x plus 1 into derivative of e raised to 4x is e raised to 4x multiplied by 4. Now we have to substitute this second derivative and first derivative as well as y term in this equation and solve for a1 term. Then we will get a1. We will call this one as 1, this one as 2 and this one as 3, and we will call this one as 4. So substituting 1, 2 and 3 in 4 and solving for a1, we will get a1 value. Let us simplify this one before substituting into the first equation. So this becomes e raised to 4x into a1 multiplied by this 4 plus 4 into 4x plus 1. So this becomes, here we were having one bracket term. So this becomes e raised to 4x into a1 plus 4 into 4x is 16x plus 4 plus 4, that is 8. So we will call this one as 1 and we will substitute this 1, 2 and 3 in our first equation. So this equation, when substituting these all terms into this equation, what we will get is a1 e raised to 4x into 16x plus 8 minus 7 into y dash. Y dash is this one. So this become a1 e raised to 4x into 4x plus 1 plus 12 into a1 x e raised to 4x equal to 2 e raised to 4x. So then we have to solve this one. So what we will get is a1 into 16x plus 8 into e raised to 4x minus 7 multiplied by 4x, that is 28x a1 e raised to 4x plus 7 minus 7 a1 e raised to 4x plus 12 a1 x e raised to 4x equals 2 e raised to 4x. Now we can equate coefficient of e raised to 4x from LHS and RHS and we can solve for a1. So what we are left with? We are left with a1 into 16x plus 8. So coefficient of e raised to 4x is a1 into 16x plus 8. Similarly here what we will get is minus 28 x a1 minus 7 a1 plus 12 a1 x equals 2, because we are equating only coefficient term from both LHS and RHS. Now what we are left with? Here we are having 116 a1 x and here we are having minus 28 x a1 and here one more 12 a1 x. So what we are getting here? 16 minus 28 plus 12. So we will write as 16 minus 28 plus 12 into x a1. So here this term and this term and this one gone and we are left with a1 8 minus 7 a1. So this will be plus a1 equals 2. Now here this one 16 minus 28 is minus 12 plus 12 is 0. So this term gone. So we are getting a1 equal to 2 here. So a1 is equal to 2. So this 2 we will substitute here. So our particular integral will be 2x e raised to 4x. So what is our final solution? So our final solution will be, I will write it here as y equal to 2x e raised to 4x plus a e raised to 4x plus b e raised to 3x. So thus solved.